Huwag po kayong manahimik o magdalawang isip. Kung may alam kayong katiwalian o reklamo, ipaalam ninyo sa sumbungan ng bayan. Narito po ang aming hotline.
Hello, it's me again. So after talking about your derivatives, similar to your single variable functions, we can also talk about differentiability, differentials, and local linear approximation, even in your multivariable functions.
But before that, let's have some reminders. First, make sure you have already watched the lecture video for this topic before watching this discussion video. And of course, feel free to pause or play this video anytime according to your own pacing.
So first, differentiability. You say that a function of x and y is differentiable at a, b if the first partials at a, b both exist and this limit right here is equal to 0 whenever delta x, delta y approaches 0, 0. And r here, you know from your lecture to be this function. And so, we can transform this limit, the numerator in particular, by replacing all x and y's in r with a plus delta x and b plus delta y respectively. So I will have f of xy becomes this. Then I will distribute the negative here. So I have minus f of ab minus f sub x of ab, x minus a. Since x now becomes a plus delta x, this becomes a plus delta x minus a, or just delta x, and then minus f sub y of ab times delta y, all over the same denominator. So this will be the form that we will be using for our discussion. And aside from your definition, you also talk about two important facts about differentiability. First, if f is differentiable at a specific point, then it automatically happens that f is continuous at that particular point, similar to your single variable function. This is very good because this tells us that once my f happens to be not continuous at a point, then it will automatically make my f not differentiable at a point. Otherwise, it will violate this fact. And number two, my first order partial derivatives should exist and should be continuous at a particular point for my function to be differentiable at that point. Okay, now these two will be our tools in identifying whether a function is differentiable at a point or not. Now, let's summarize these conditions. So there are two ways for a function to be differentiable. First, if the first partial at AB are continuous based from the number 2 of your theorem. And then second one, based from your definition naman, no, if this limit happens to be 0. Meanwhile, there are four possible ways for your function to be not differentiable at a point. First, if the function value at the point does not exist at all, because that means that it's not continuous. Again, para maging continuous, kailangan mag-exist muna, di ba? If hindi nag-exist, hindi continuous, not differentiable. Number 2, if the limit does not exist, hindi na naman continuous, hindi na naman differentiable. Third condition is that if the first partials at AB does not exist, because these are parts of your definition, no? Aside from the limit, kailangan din to, di ba? And number 4, if this limit happens to be not 0, pwedeng does not exist, or pwedeng nag-exist naman pero hindi lang 0 yung limit, no? Then hindi pa rin differentiable yung f mo at AB. Okay, so I have a suggested flow that we can follow to check if a function is differentiable at AB. The easiest thing to check first, because you have many conditions, no, you don't know which to check first. So it's best to check for continuity first because it's very easy. Check for the function value, check for the limit, and check if they're equal. If it's not continuous, tapos ka na. Hindi differentiable by one of your conditions. But if it happens to be continuous at AB, wala ka pang masasabi, you have to do something else. And the next you can do if nag-continuous is check the first partials at the point. Kapag hindi nag-exist, hindi na naman differentiable, tapos ka na. Pag nag-exist, yung first partials, wala ka pang masasabi, proceed ka sa checking for continuity. Check mo kung continuous yung first partials at AB. If not continuous by one of your theorems, differentiable. You're done. But if not continuous, so ito yung last, no? Continuous, yung f, yung first partial nag-exist, pero yung first partials mo hindi continuous, your last resort will be to check for this ugly limit, no? And ito na yung last kasi sure ka na may conclusion ka. Kapag equal 0 yung limit na to, differentiable. Kapag hindi 0, not differentiable. Okay? So let's apply these steps, no, to check if these given functions are differentiable at the given ABs. First, let's have this. Let's check for continuity. Yun yung first step natin, no? Check natin if continuous itong f kay 1, -1. So, check ko muna function value. Yun yung first condition for continuity, di ba? So, what happens here if I replace all x with 1 and all y's with -1, I get this. Numerator becomes -2. Denominator becomes 0. Undefined. Tapos ka na, hindi nag-exist ang function value, hindi continuous, hindi differentiable at 1, -1. Very easy. Let's see number 2. I want to check if this is continuous at pi 0. Is this continuous? Yes, because the only terms involved are cosines, ilob ng cosine polynomial pa, tas exponential, which all we know to be continuous everywhere. So, continuous tayo. Okay yung first step. Check na ano ulit yung next. Check natin yung first partials at pi 0. But to check for the first partials at pi 0, kailangan ko muna i-check yung f sub x and f sub y of xy. So, f sub x of xy, I need to do product rule, no? Because 3 to the x ito, may x. Tas ito, may x. Again, I will treat all y as constants. So, copy the first. 3 to the x, derivative ng second is negative sign x plus y. Tapos, derivative ng x plus y, 1 lang. Plus, copy the derivative ng first, 3 to the x, ln 3, times copy the second na cosine. Okay? Now, f sub y, no? All x's will be treated as constant. So, my f sub y will be this. 3 to the x will be a constant. Tapos, derivative ng cosine x plus y is negative sine x plus y times 1 lang. Derivative lang ng x plus y with respect to y. Now, originally, I'm checking for the first partials at pi 0. But if you look at your first partials here, yung general forms nila, you can immediately see that they are continuous everywhere because the only terms involved, no, are polynomials, sine and cosine and exponential. Okay? So, in this case, tapos ka na, no? Continuous everywhere, and in particular, your first partials are continuous, no, at pi 0. Therefore, differentiable. Not just in pi 0, but actually differentiable everywhere. Now, let's have number 3. So, to check for continuity, again, that's our first step. Unlike kanina, no, sa number 2 na we can already say that it's continuous everywhere, ito hindi kasi sine inverse is only continuous in its domain. So, what I can do is check manually. No, first, check ko yung function value. Again, that's the first step in checking for continuity, di ba? So, if I have f of negative 2 1/3, no, then I have this. Negative 2 squared is 4, and then 1/3 times 9 is just 3. So, I just get sine inverse of 1 or just pi over 2. So, the function value exists. Does the limit exist? Let's check. To get this limit, yung loob, pwedeng i-plug in ko na lang, no, from one of your properties from your previous lectures. Since yung loob naman ay polynomial lang, so I just get sine inverse of 1 or pi over 2. So these two are the same. Therefore, it's continuous at negative 2 1/3. So we're good. Now let's check for your first partials at negative 2 1/3. Do they exist? If I check my first partial with respect to x, so ang derivative ng sine inverse is 1 over square root ng 1 minus squared nung nasa loob ng sine inverse. So something like this. Tapos times derivative pa nung x squared minus 9y with respect to x, that's just 2x. So yan yung partial ko with respect to x. Hindi ko makonclude na ito ay continuous everywhere, no? Kasi ano to rational na may radical pa. Hindi tulad kanina na skip ko na yung step, no? At nasabi ko na agad na continuous everywhere yung partials. Ito hindi. So I have to manually check for the first partial at negative 2 1/3. If I check this, what do I get? No, yung taas magiging negative 4. Yung baba, sabi nga natin yung x squared minus 1 ay nagiging 1. So I have 1 minus 1. So this is non-existent. Okay? So tapos ka na. Now, one of your first partial does not exist. Therefore, it's not differentiable. So maganda rin na pagka-check mo kung halimbawa pagkakuha mo ng first partial with respect to x, no? Hindi mo agad masabi na continuous siya everywhere. I-plugin mo agad, no? Kasi baka sa f sub x pa lang mag-fail ka na, no? At least tapos ka na. Kesa computein mo pa si f sub x and f sub y, tapos tsaka mo i-plug in sa pareho, no? Baka yung pag-compute ng f sub y is hindi naman na pala kailangan. Pero pag nag-exist sa f sub x, hindi ka pa tapos kasi baka sa f sub y naman, hindi mag-exist. Okay ba yan? So, ito ay not differentiable. Now, puntahan natin yung tatlong piecewise functions sa examples, no? Let's start with this one. So, I want to check if this is differentiable at 0, 0. First, check natin ang continuity at 0, 0. It exists ang function value, no? Ayan, no? Outright defined na siya. F of 0, 0 is just 0. However, does the limit exist? So, to check for the limit as xy goes to 0, 0, no, of this piecewise function, ang titignan ko lang, no, alam niyo na to, no, ang titignan ko lang itong upper function because again, my xy just goes close and close to 0 but not necessarily at 0, 0. So, ito lang gagamitin ko, no? Okay? Ano to? Ito yung kamukha ito ng mga examples nyo sa continuity, no? Ito yung mga tipo ng limit na hindi nag-exist because of different limits from two curves. Right? So, let's show, no, na ito ay hindi actually nag-exist, itong limit na to. Halimbawa, pag kinuha ko yung limit along x equals 0, nito, ang mangyayari, yung lahat ng x magiging 0 lang. So, I have 0 over negative y squared, or that's just, well, 0. Limit niyan 0 lang. Diba? Pero, if I use the curve, yung usually goal natin, ano, no? Gusto mo mapagsama tong terms sa denominator para may makancel ka, tapos may matirang constant, no? Halimbawa, itong y squared, gusto mo gawing x to the 6 para mapagsama mo to. Kaya ang kukunin natin curve, yung y equals x cubed. No? So, if I do y equals x cubed here, replacing all y's with x cubed, so yung taas, naging 5x cubed, yung baba, naging 3x to the 6 minus x cubed squared, which will give me, no, this, yung taas, 5x to the 6, yung baba, 3x to the 6 minus x to the 6, that's 2x to the 6. I can cancel x to the 6. I will be left with the constant 5/2 as my limit. So, nagkaiba yung limit sa dalawang magkaibang curves. Therefore, this limit that I'm looking for does not exist. So, therefore, hindi na rin continuous, hindi na rin differentiable. And we are done. Okay? Good. How about this one? Another piecewise function. Again, check ko ulit ang differentiability at 0, 0. Function value clearly exists, equal to 0. Limit ba nag-exist? This limit actually exists and is equal to 0. And we will show it using your epsilon delta definition. No? So, I will just go by it quickly. So, to prove that, let epsilon be greater than 0. Hanap ako ng delta such that, yung square root nung x minus a squared plus y minus b squared, in this case, my a and b are both 0, no, is between 0 and delta, but this radical here is just square root of x squared plus y squared, and it must happen that the absolute value of f of x minus L, in this case, this function, ito yung kinukuhanan ko ng limit, minus 0, no? This should be less than epsilon. And it will happen if ganito siya, no? Yung baba, pwede ko nang alisan ng absolute value. Tapos yung taas, yung y squared, pwede ko ring ilabas because these are surely positive. Tapos itong term na to, pag binawasan ko ng x squared, yung ilalim lalaki. Tama, kasi yung denominator liliit. And then I can cancel x squared. 8 absolute value of x is just 8 square root of x squared. Square root of x squared, mas maliit yan sa square root of x squared plus y squared. No? And therefore, no, but square root of x squared of y squared is less than delta. So therefore, this is less than 8 delta. So I can take my delta to be epsilon over 8. No? And I have proven that this limit is equal to 0. Ang point ko dito, this is continuous at 0, 0. So we're not yet done. Wala pa tayong conclusion. We have to proceed. First partials kaya nag-exist. Unfortunately, unlike yung first 3 examples, no, na para ma-check yung first partials, kunin ko lang si f sub x and then plug in. Ito, since naka-piecewise siya, I have to use the limit definition of your partial derivatives. So, tanda ba? Itong f sub x of 0, 0 is just this limit here, no? And etong sa f of x, 0, ang gagamitin kong definition sa piecewise ko, yung nasa taas, because again, x just goes to 0. So, x0 is not necessarily 0, 0, no? So, gamitin ko yung taas. Pag ginamit ko, pag ni-replace ko lahat ng x dito with 0, I will get this one minus f of 0, 0, clearly defined to be 0, over x lang yan. Ano ito? Ito, 0 na to, no? This is 0 over x squared or just 0. So, I get my limit to be 0. No? Pag kinuha ko, so, nag-exist yung f sub x. Check natin sa f sub y kung nag-exist ba o hindi. Definition. F of 0y minus f of 0, 0 over y minus 0. So, ganun ulit. F of 0y, I will use this to evaluate 0y. Therefore, I will replace all x's with 0. I will get something like this. Tapos, f of 0, 0, 0 lang over y. Etong term na to magiging 0 over y squared lang. No? So, 0 minus 0 over y, 0 over y, limit niyan 0, nag-e-exist din. Okay? So, hindi na naman tayo tapos because the first partial existed. Tanong ngayon, no? Are your first partials continuous? Well, since hindi nga natin siya makuhaan ng f sub x of xy tsaka yung general na f sub y of xy, let's skip that step. Hindi natin siya kayang gawin. Okay? So instead, tayo po ay dumiretso na sa ating limit definition for your differentiability. Etong limit na ito. Okay, so replace ko lang lahat ng a at b ng 0 because that's what I'm looking for. That's what's given. Game. So if I do that, f of 0 plus delta x, 0 plus delta y is just f of delta x delta y. So again, gamitin ko yung taas na function sa aking piecewise. F of 0, 0 ay 0. F sub x of 0, 0 na compute natin kanina to be 0. And f sub y of 0, 0, sabi rin natin, no? Nahanap natin kanina to be 0. Okay? Over this square root. So, simplifying yung numerator, etong tatlong to, 0 lang yan lahat. Ito namang fraction na to, etong delta x squared tsaka delta y squared, pwede ko ibaba dito. So, yung denominator ko magiging delta x squared, delta y squared raised to 3 halves. Because ito, naka-raise sa 1, yung delta x squared plus delta y squared, ito naka-raise sa 1 half. Kaya naka 3 halves iyan. Tapos yung taas, kinopya ko lang. Okay? Now to check, no, if where this limit goes, I can pick two different curves again, and you will actually see that this limit is non-existent. No? Halimbawa, I can have along delta x, delta y. Along delta x, delta y, if I replace all the, again, ang delta x at delta y ang variables mo dito, ha? So if I replace all delta x with all delta y's with delta x rather, now I have this. This time, limit na lang as delta x approaches 0. So pwede kong pagsamahin yung ilalim. So I get 2 delta x squared raised to 3 halves. So etong ilalim, pwede kong i-distribute yung exponent, no? I just have yung 2 to the 3 halves, square root of 8 lang yan. Tapos yung delta x squared raised to 3 halves, parang magka-cancel lang yung 2, kaya delta x cubed na siya. Delta x cubed can cancel, 8 over square root of 8 will just become square root of 8. Now, actually, I don't have to check for another curve, no? Hindi ko na kailangang maghanap ng ibang curve because the limit along this curve is square root of 8. So, kung nag-exist man yung limit na yan, ang sagot, square root of 8. Kung hindi nag-exist, edi hindi nag-exist yung limit na yan. In any case, yung limit na to, hindi 0. Eh, yun naman yung pakialam mo eh, no? So, hindi siya 0. So, wag mo nang tapusin yan. Basta hindi 0 yung limit mo, alam mong hindi 0 yan. Not differentiable, and you are done. Okay? And now, for your last item, let's have this example, no? You can show that this is continuous at 0, 0. Gamit kayo ulit ng limit definition, kaya nyo yan. Then, the first partials are actually both 0. Use again the limit definitions. So, kayo na pong bahala dyan. I will leave that to you. No? Skip na ako sa last step ulit. No? Last resort ko. Kasi, yung mga ito, wala tayong conclusion dyan. Eh, no? So, itong limit ulit na to. Okay? Balikan natin ito. But this is actually equal to 0. No? If you check. No? Inayos ko lang ito, no? Yung A at B, ginawa ko lang 0, 0. Tapos, in-evaluate ko lang dito si delta x, delta y. No? Tapos, itong delta x squared plus delta y squared, sinama ko lang dito. Para yung square root, nawala yung square root. Yung taas, ganun pa din. Now, this is equal to 0 and you can actually show that by using your delta epsilon definition for limit, no? Daanan ko lang to very quickly. If I let my epsilon be a positive number, no? Ito yung assumption sa ating limit definition. So, then yung f of x minus L ay ito. Pwede ko nang alisin yung absolute value. Lagi naman yung positive. Actually, equal yan. Hindi pala less than. Sorry. Anyway, this is equal, but this is less than naman dito, no? Tinanggalan ko ng delta y squared sa ilalim, liliit yung value, ay yung denominator, so lalaki yung kanyang value. I can cancel delta x squared, delta y squared, ang matitira, no? Na definitely mas maliit sa pag sinamahan ko siya ng delta x squared, no? But ito po is just square root of delta x squared, delta y squared, na naka-square root. So pag ini-square ko to, both sides, this is just less than delta squared, no? So if I take my delta to be square root of epsilon, no, this will be epsilon, and that is, that proves that the limit is equal to 0. Therefore, this function is differentiable at 0, 0. Okay, so I have showed different cases, no, na kung ano-ano yung pwedeng mangyari sa function mo, no, kung differentiable ba siya because because continuous yung partials, not differentiable ba because not existent yung function value, or baka hindi 0 yung limit definition, no? Okay, so I highly suggest that you follow the flowchart. Okay?
Ayoko na!